is a continuation of section 6.2, talking about parabolas. And remember, we're talking about them as geometric objects, so they can open right, left, up, or down. So here's a problem from the homework where it says the vertex is at 4, -2. So I'm going to draw the graph of vertex at 4, -2. So here's my vertex. And the focus is at 6, 1, 2, 3, 4, 5, 6, -2. So I can see the relationship of the vertex to the focus. So I can see that the parabola must open right because the focus has to be inside the parabola. And then we know that A is the distance from the vertex to the focus. So that's going to be 2. So A is 2. So my equation would be, let's see, this is my home base, y equals x squared. So this one's going to be x equals y squared, basically. Well, now I know that y squared equals 4a, which is 8x. And because there's no negatives, that's going to open to the right. So this is unshifted. This would be if the vertex was at the origin. So now we have to account for that the vertex isn't at the origin. So we replace y with y plus 2 quantity squared because the y coordinate of the vertex is -2. And that equals 8 times x minus 4. So then do a quick double check and make sure the vertex really is a point on the parabola. It makes the equation true. Okay, and then we know a is 2. So we know 4a is 8, and this is the focal diameter. So at the focus, if the focal diameter, the width, is 8, means I need to go 4 in each direction. So 1, 2, 3, 4, up, and 1, 2, 3, 4, down. And I need to find those latest rectum points. But I usually draw them on the graph and then read the coordinates off. So it's 1, 2, 3, 4, 5, 6, comma 2, and 6, comma -6. Then again, I do a quick double check and plug these numbers back into the equation and make sure they make the equation true. Looks like they do. So these are the latest rectum points. This is the equation of this parabola. And then we can make the graph really easily now that we have the vertex, the latest rectum points. So make sure you label your axes on all of your graphs. And that's number 30. Okay, so let's look at number 32. This one we have the vertex at 3, 0. And the focus at 3, -2. So we can see that this one needs to open downward. So we can see immediately by the relationship of the vertex and the focus that this parabola has to open downward. Okay, then we know A is the distance from the vertex to the focus. So again, that's 2. So 4A is 8, which is the focal diameter. Okay, so this parabola is opening downward, but it's basically a y equals x squared parabola, but it's going to be x squared equals negative, and then 4a is 8y, but this is unshifted. So then the last thing I do is the shift. I say I need x minus 3 squared, replace x with x minus 3 because the vertex isn't at the origin. But the y direction is not shifted. So don't subtract anything from y. So here is the equation of this parabola. And again, just do a quick check and make sure that the vertex does make the equation true. Okay, so then we know if 4a is 8, then a must be 2. So that's going to be the distance from the vertex to the focus, but then the focal diameter is 8, so that means at the focus I go 1, 2, 3, 4 to the left, and 1, 2, 3, 4 to the right to find the latest rectum points. So I read them off my graph. 1, 2, 3, 4, 5, 6, 7, comma, -2. and then -1, -2. And again, take a moment and check and make sure that if you plug 7 in for x and -2 in for y, it makes the equation true. Try plugging in -1 for x and -2 for y, makes the equation true. So I'm confident that those are the latest rectum points, and here's the graph of my parabola. Okay, so now we're going to try, given an equation, find all the important features. And this equation, let's see, y equals x squared is this parabola. That's the one I use as my home base. So this one opens up because I'm not seeing any negative. So then I can see that the vertex is -4, -2, because x has been replaced with x minus -4, and y has been replaced with y minus -2. So I can tell where the vertex is. So I'm going to draw a picture and say the vertex is at -4, -2. So here's my vertex. Then this quantity 16 is your 4a. So 4a is 16. So a is 4. So the distance from the vertex to the focus is 4, and we're opening up. So I need to go up from the vertex to find the focus. So the focus is the point -4, comma, +2. Okay, then at the focus, the parabola needs to be 16 wide, so 8 each way. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So I can read off my graph the coordinates of these points. 1, 2, 3, 4, comma, 2. And -12, comma, 2. And again, plug these into your equation and make sure it really works. So then I can draw my parabola, and I've found the vertex, the focus. I need the directrix. So if I go from the vertex to the focus and it's 1, 2, 3, 4, then to go from the vertex to the directrix, it's also 1, 2, 3, 4. And it's going to be the horizontal line, y equals -6. So here's my directrix. And then we graphed the equation. Okay, so that's number 42. And the last two involve completing the square. So I'm going to walk through that with you. Number 48, I'm going to keep the x terms on one side and use algebra to move the other terms to the other side. And then I have x squared plus 6x. So if you remember completing the square, you take the 6 divided by 2 and square that, and you get 9. So that means you need to add 9 to both sides to complete the square, so that on the left you have the perfect square, x plus 3 quantity squared. And then you're going to have 4y plus 8. But if you look at the standard form, there's not going to be a 4y plus 8 looking expression there. So I need to factor out the 4 so I can see what the vertex is and see what the 4a is. So here's my 4a is 4. The vertex is -3, -2. So the vertex is at -3, -2. Here's my vertex. If 4a is 4, then a is 1, and that's the distance from the vertex to the focus. And then I need to think about which kind of parabola is this. So it's basically a y equals x squared. So it opens up. Not working on this one right now. Okay, so it opens up, so I know I need to go up to find the focus. Okay, so then the parabola focus diameter is 4, so I need to go 2 to the right and 2 to the left and find the points of the latest rectum are -1, -1, and -1, 2, 3, 4, 5, -1. And again, plug these into your equation and make sure they really work. Looks like they do. Then you can draw the graph. And we've completed the instructions except for finding the directrix. So we found the vertex. The focus, I read off my graph, is -3, -1. From the vertex to the directrix is the same distance as from focus to vertex. So this is the directrix, is going to be the line y equals -3. Okay, and the last problem is y squared plus 12y equals -x plus 1. And this one's a little trickier. To get the square completed, I need 12 over 2 squared. So that says I need to add 36 to each side. So I have y plus 6 quantity squared equals -x plus 37. Well, again, you never have two terms on the right. You need to factor out whatever's multiplying the x or the y. So you get negative quantity x minus 37. So your vertex is going to be 37 comma -6, because x has been replaced by x minus 37, and y has been replaced with y minus -6. So I'm going to do a really weird scale here and just say, that's 37. So I have 37, -6 for the vertex. Well, now A is 1. Oh, sorry, 4A is 1. So that's the focal diameter. This is a really narrow parabola. And the distance from the vertex to the focus is 1/4. And let's go back here to the equation and say, oh, this is not the y equals x squared type. This is the x equals y squared type, which opens right or left. And this negative tells me it opens left. So the way I get from the vertex to the focus is go left. But I only go 1/4 to the left. So this point is going to be 36.75, 1/4 to the left. So the focus is at 36.75 comma -6. So there's your focus. And then at the focus, the parabola is only 1 wide. So it's very narrow. So you go 1/2 up and 1/2 down. So those points are still going to have 36.75 as their x coordinate. But then it's going to be -6.5. and -5.5. So these are the latest rectum points. And you can see it's a very narrow parabola. And that's all I have for this section.